Apart from a few memorable events, we don't get too much winter weather here in the low country. There was the snow back in 2018 and the historic and only white Christmas in Charleston after Hugo in 1989. Then there's our ice storms, which just cause headaches. Predicting what will fall, snow, ice, or just plain rain can also be a headache. In my opinion, it can be one of the most difficult weather forecasts to make, as a lot of variables have to be considered, most important of which are temperatures at different levels of the atmosphere. Weather balloons are the main way to measure this, taking readings from the surface to nearly 100,000 feet. I could explain what each type of winter precipitation looks like on this diagram, called a Skew-T, but as the saying goes, cookies make everything, including explaining science, better. In front of me are different variants of sandwich cookies, each representing a different type of winter precipitation. The only difference between them is the amount of icing, symbolizing the amount of warm air in the atmosphere. More icing, a bigger layer of above freezing temperatures above the ground and below the cloud. Up in the clouds, nearly 5,000 feet up, all precipitation starts as snow. Let's start here. If there's a lot of that warm air, snowflakes will melt and fall as liquid all the way down. That's as double stuff. There isn't any part below freezing, so we just get cold rain. It gets a little bit more complicated when we add a layer of below freezing temperatures but still keep a solid chunk of warm air. That's this regular Oreo, or freezing rain. Snow melts and falls as rain most of the trip down, but encounters a pool of cold air near the surface, cooling it down, but not long enough for it to freeze as it lands and instantly freezes on surfaces like power lines, roads, and tree limbs. We don't want this. But if that wedge of warm air high up in the atmosphere is even shallower, let's say this Oreo thin, there's more time for that melted snow to refreeze into ice pellets, or sleet. It's similar to what happens during freezing rain, but it's easier to handle as ice pellets bounce off tree limbs and power lines. It's still not snow, as even though there's a lot of that cold air, there's a pesky thin layer of warm air still present. To see the fluffy stuff, we have to make sure there's no warm air at all in between the snow that's falling and the surface. This is my favorite part. There's no warm air. Snowflakes fall, never encountering any warm air, and will stay as ice from the clouds all the way to the surface. These are the possible outcomes in a winter storm. Figuring out which one we could see is the tricky part. Small changes in temperature can make a huge difference. Look at the difference between rain and freezing rain. One leads to a soggy cold day, the other, numerous power outages and traffic accidents. If I had to choose, I'd take the double stuff, but no matter what, you can count on us to tell you what cookie to expect the next time a winter system eyes low country. For this week's Moment of Science, I'm Storm Team 2 meteorologist David Dixon.